Alright. 5.2 Trigonometric functions of real numbers. So let's get a couple of things out of the way. One, if I have a circle, a unit circle to be specific, if I cut it in half, if I take each quadrant and cut it in half, this is 0, and it runs all the way to 2 pi because that's s equal theta. This is half of it, that's pi. This is half of that. When I say half, you multiply by a half, don't divide by 2, because with fractions it's a lot easier just to multiply by the reciprocal instead of dividing. So 0, pi over 2, 2 pi over 2, 3 pi over 2. Those don't change. We know this point is 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. This point is 1, 0. Negative 1, 0. 0, 1. And 0, negative 1. Now, if I was to go ahead and take half of this, which is this, if I multiply by a half, that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And if I look at this circle, if I cut each quadrant into 3 parts, 3 equal parts, assume those are 3, they're not, but let's say assume they are, because I'm not going to use a protractor to measure those. So, if this is pi over 2, and this is, I'm breaking this into 3 equal parts, this is 1/3. 1/3 of pi over 2 is 1 pi over 6. So this is 1 pi over 6, 2 pi over 6, if I reduce that, 3 pi over 6 reduced, 4 pi over 6 if I reduce it, 5 pi over 6, 6 pi over 6, we know that already, 7 pi over 6, this is 8 pi over 6 if I reduce it, 9 pi over 6 reduced, 10 pi over 6, 11 pi over 6, and 12 pi over 6 is 2 pi. If I am to figure out that these points I know, and if I map the 36, so this is 45 here, right? If I was looking at an angle of 45, this is 1, this is 1, this is radical 2. But I know here this is a unit circle, so this is a 1. What that means, to make this a 1, I would divide this by 2. And in trigonometry, they say, hey, cosine of 45 is the x, that's 1 over radical 2, and sine is 1 over radical 2. They go to this angle, they say that's 30 degrees. Assume this is 30 degrees. Then, if this is 1, this is 2, this is radical 3. So to really get it down to be matching what we need, they divide everything by 2, make that a 1, make it a unit circle. So again, this point, which is x and y, just like this point is, this point right here, I could label as cosine of 30 degrees is the adjacent over 1, the adjacent over the hypotenuse, and y is the 1/2. And if I go to 60 degrees, cosine of 60 degrees would be the adjacent over the hypotenuse and radical 3 over 2. So basically, knowing at 0, at pi over 2, at pi, at 3 pi over 2, and at pi over 6, and at pi over 4. If you know those values, pretty much you're set. I claim if you could keep those just for the angles, to know where are you, and keep in mind that then along with those two triangles, and you don't even need to force it to be a 1. You could just leave it as we've been using all along. The reason they don't do that because they really don't use geometry with trig. They do it on their own. So if I look at this, using the reference angle, this is 60 degrees. Find the exact value. 60 degrees is right there. Sine is the opposite over the hypotenuse. Again, the question is always, which quadrant is this in? That's going to be the question all the time. Now, if you take the time on your test, or wherever you need this, if you take the time to draw the two circles that I just did, which don't take that long at all, to figure out where each angle is, or just use the reference, then you're set. Where's 2 pi over 3? We know this is pi, which is 3 pi over 3, or if you have those drawn, you know exactly where 2 pi over 3 is. And in this quadrant, the sign is positive. And that's pretty much it. So the over 3, again, it's 60 degrees. Cosine of 60 degrees is 1/2. And we know this is in quadrant 2. So in quadrant 2, only sine is positive, which means this is a negative. And since we're dealing with the same angle, we know where we are, and we know what this angle stands for, right? So we know this is the opposite over the adjacent, except in this quadrant, it's negative. 45 degrees, right there. Sine is the opposite over the adjacent. And 5 pi over 4, if this is 4 pi over 4, 5 pi over 4 is right there. And in this quadrant, again, if I'm looking at this, I could see where 5 pi over 4 is. 45 degrees, I know tangent is, and again, it's right there, opposite over adjacent, that's 1 over 1. 5 pi over 4 is in this quadrant, and it's a positive 1. Pi over 3 is 60 degrees. That's the hypotenuse over the adjacent. And where's 4 pi over 3? This is 3 pi over 3. 4 pi over 3 is right there. Only tan is positive. Again, if you have this in front of you, you could look at the red, and that pretty much tells you what you need every time. And that saves you a lot of work if you have that next to you. 11 pi over 6, 30 degrees. 30 degrees is right there. Tangent is the opposite over the hypotenuse. The adjacent, I'm sorry. 11 pi over 6, if I glance at this, I could see where it is right away. So I know you're right. It's right here, all students. So here, only cosine is positive. That means that's a negative. By the way, I do want to mention, if you rationalize the denominator, this is radical 2 over 2. If you rationalize the denominator, so on the homework, you should rationalize. For the exam, I can care less. this is where the triangles can't help you. 3 pi over 2, I know where 3 pi over 2 is. 3 pi over 2 is right there. And cosecant is 1 over the sine. Isn't the sine the y, which is a negative 1? So there it is. So any point on the actual x-axis or the y-axis, the triangles can't help you. How about this? 60 degrees. If I look at, and again, if I need to, I could draw the triangle really quick. Doesn't take that long. 1, 2, radical 3. That's 60 degrees. That is adjacent over opposite. That is 1 over radical 3. Where's negative 60 degrees? Isn't that right there? You go in negative rotation. And in this quadrant, isn't cosine positive, which means everything else is negative? Again, the back of the book will have a negative radical 3 over 3. They rationalize. On a test, I don't care about it, but on the homework, I do. You should rationalize. I'll leave that here. How about this problem? If I rotate in negative rotation to negative 3 pi over 2. If you don't like that angle, add 2 pi to it. It's pi over 2. Bottom line, you're right there. On the unit circle, isn't that 0, 1? Cosine, isn't cosine the x? And that's how we're going to do those. Pi over 6, 30 degrees. There's 30 degrees. Opposite over hypotenuse. Where's negative 5 pi over 6? This is negative 6 pi over 6. So negative 5 pi over 6 is right there. And in this quadrant, only tangent is positive. And pi over 4 is the nicest of them. I could draw that too if I need to. It doesn't take that long at all. The reason I emphasize this a lot more than the book does here, because in calculus you need to know what these values are. It's very efficient to just draw the triangle. 45 degrees secant is the hypotenuse over the adjacent. So the answer is radical 2 over 1. The question is it positive or negative? Negative 3 pi over 4 is right there. Only tangent is positive, which means this is negative. So that's how we're going to be playing those. Now, assume that S, look at the keyword. If they say it's on a unit circle, if it's on a unit circle, then I know that the x and the y can be replaced by a cosine of the angle and sine of the angle. They say, given the following terminal point S on the unit circle, determine the value of sine of S. So if this is S, the sine of S, the cosine of S, well, sine of the S is automatically the Y, and it's right there. Cosine is the X, and tangent, isn't that sine of S over cosine of S? Well, sine is negative radical 3 over 2, and cosine is 1/2. The 2's cancel out, and what are you left with? Negative radical 3. And that would be my answers. And here the same deal. I know the sine of this angle is the Y. I know the cosine is the X. And I know the tangent is the sine over cosine. So I use identities here. Sine is 5 over 13 negative. Y is 12 over 13 negative. That is positive 5 over 12. There's tangent, there's sine, and there's cosine. If I know it's a unit circle, automatically that will work. If they want me to figure out where am I, and again, that's half of the problem always in trig. Half of the problem is knowing which quadrant am I in. If I told you, and you know that Sine is negative. Isn't sine negative in those two quadrants? Cosine is positive. Isn't cosine positive in those two quadrants? So can you tell where you are? Quadrant 4. That's where S is. And if I proceed and I tackle the next problem, same deal. That is, if I look at this, say, okay, well, let's see. Where's tangent negative? Tangent negative in two quadrants, right? Tangent is negative in quadrant 2 and quadrant 4. And where is secant associated with cosine? Where's cosine negative? Cosine is negative in those two quadrants. So I must be in quadrant 2. And it's very important to know which quadrant you're in to know whether to have a plus or a minus. And now, what if they say, find the value of the 6 trigonometric functions? I could use identities, or I could do better than that. I could use geometry. That is, first I need to know which quadrant I'm in. If sine is negative, and tangent is positive, doesn't that mean that S is in quadrant 3? If I know S is in quadrant 3, I'm pretty much set. Why is that? Because I know what to do. I know sine is the opposite over the hypotenuse, and I am in quadrant 3. We always go to the x-axis if you recall. Sine is the opposite over the hypotenuse. One of those two sides is negative. What would that be? Well, of course, the y. This can never be negative because it's really the radius of a circle. Now what? Now I need to figure out the missing side. Well, I'll say 3 squared equals a negative 1 squared plus x squared. 9 equal 1 plus x squared equal 8, x equal plus or minus 2 radical 2. In this quadrant, is x positive or negative? Isn't x negative in this quadrant? So what do I need? Find the value of the trigonometric functions. I would like to know what is the sine of theta, what is the cosine of theta, and what is the tan of theta, and I assume you could find the other three. So if I was to say, what's the sine of theta? Wouldn't that be the opposite over the hypotenuse? And it's negative. What's the cosine of theta? Cosine of theta is the adjacent divided by the hypotenuse. And the tan of theta would be the opposite over the, those cancel out. And if you rationalize, again, this is a fine answer, that's all I want. If you rationalize the denominator, you'll get 1/2. No, radical 2 over 2. It doesn't matter. And how about if I wanted to do part B? The same deal. If I glance at this, say, okay, well, first I need to know which quadrant am I in. Right? So that's the first order of business every single time. So I look at this, say, okay, let's see. Tangent is positive in those two quadrants. And secant associated with cosine is negative in those two quadrants. I happen to be in quadrant 3 again. That's not what I wanted. But it's okay. So I am in quadrant 3. I was hoping to be in quadrant 2. I'll tell you what, I can fix that. No, I can't. That's okay. So once I know that I am in quadrant 3, I'll draw the triangle. Tangent is the opposite over the adjacent. Be careful, in this quadrant, both of these are negative. And if I figure out this is the square root of 10, 9 plus 1. And I could say the sine of theta is the cosine of theta is, and the tan of theta is. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And that would be a fine answer with me. Here I have space. If you want to rationalize, you're welcome to multiply by radical 10 over 10. And that will remain. And that's pretty much it for this section. So hopefully this is the second time you're seeing this. This is reinforcing what you already learned.